functions can return multiple values. Some functions do. Let's say we're going to have function m takes a, b, c, and returns. That's interesting. What do I want to do? Trying to figure out what I want to do. One plus one minus, like plus plus, and well, sort of. They just increment. They're not destructive though. So if I say m 1, 2, 3, that's giving me back 3 values. If I want to see what the last value was, it's 2. So it's returning these 3 values as separate values, not as a list, for example. If I want to catch them, I use this very long thing called multiple values set queue. And now the thing that returned was 2, but x now is 2, y is 1, and z is 9, I mean. Okay? You might find a need for that. Macros, very cool in Lisp. So for example, we can create macros however we want. This is extraordinarily confusing because you have to build the thing. What a macro does is it associates a name with an expansion. It has this variable, the variable in here, whatever you want to call them, and then you replace them with you replace parts of what you return with that. So for example, let's see something else. Let's say we want to say def macro msetq msetq, and we'll say all the rest of its arguments. We'll call it vars, and I'm going to return list multiple value setq list. Oops, I don't need to do that. I can just do var. Oops, and it also needs oops. I've got msetq. Let's do this. All right. First thing is going to be the vars. Second thing is the rest is all the things we're going to evaluate, or the form that we're going to evaluate. It does just take one form. Sorry. Long day. Okay. So msetq vars and form. Now, if I were to call that, well, let's go back and see if I may have screwed it up, which is always possible. Maybe I don't want that long thing, so I'll just do msetq, and that is exactly the same thing. I can see what it expands into by doing this, macro expand, and quoting it, and it, okay, that's cool. Did not know that multiple value setq was that. So anyhow, this is doing what you'd expect, sort of what you expect. It is replacing with multiples. It optimized it for me. It took multiple value setq, which I'm assuming is itself a macro, which I didn't realize, but they almost have to be. Yep. Okay, so it took, basically, it expanded multiple value setq, and then expanded it. It created the multiple value setq and then expanded it again into this. Okay. Now, what you should notice about this is that let's do something else so you can actually see it, because that was more confusing than not. So let's do this. We'll define a macro plus that's going to return okay. So plus 3, 4, 5 should give me the right answer. Oh, what did I screw up? Oh, no. What did I screw up? Rest L, cons plus, onto that. Well, we'll debug it. I'm sure I did it on purpose, so you'd have something to debug, right? Oh, sorry. Got carried away. Should just be a symbol there. Never mind. All right, now if I do that, notice it expands directly into that, and then if I actually call it, then it'll do it right. Okay? So we see what we did here was this macro expands into this. And that's all we defined. Also notice something else. It's not evaluating its arguments. So if I say q a3, b4, c5, you can do that with setq, by the way. They're sequential. And I say plus a, b, c. Okay, gets what you expect. macro expand this. Notice that it doesn't evaluate its arguments, ABC, or show up as ABC there. That's a good way of doing things if you want the arguments themselves without their evaluations, okay? Now, that's kind of tedious. As you can see, this thing is tedious over here, mainly because I've got all these stupid lists. Sometimes you just want to see what it evaluates into when you're creating it. So, for example, maybe what I want is this, what did I have before, the multiple value set queue, right? Well, maybe. Let's not. That was bad enough, wasn't it? You guys are all rolling your eyes at this point. That's cool. All right, so suppose I wanted that. I could also define that instead of, this is what I had before. I can define it using something called a backquote. Well, it's not something called a backquote, using a backquote. Backquote's like a regular quote in some ways, except, whoops, sorry. Except I can insert things into the backquote using a comma. So now that does the same thing I had before. Yeah, except I screwed it up. Let's see how I screwed it up this time. Ah, I know how I screwed it up. It's trying to evaluate that. Okay. Oops. There you go. All right. Now, that's not the best way of doing that, obviously. The best way of doing that is just this. Plus. And now I'd like to just insert the rest of this stuff, right? L. Well, it turns out if I put comma at L, it inserts all the elements of that list like that. And so now if I say this, this is what I came back with. Okay. So a backquote lets you create a list. Stop it. Lets you create a list like this. Okay, cool. But I can also evaluate things in there. Remember, A had the value 3. So I can do that. And then if A has set Q B, then I can do that. Okay? All set. And then I can use the at to do that. So you might find that handy. All right. Macros, other data types we might have, characters. First of all, I should say with macros, is one of the primary things that makes Lisp, or one of the main things that makes Lisp so powerful, is you can basically take macros and make Lisp into anything you want it to be. For example, Paul Graham, one of the things, he's one of the books that his book is one of the ones I recommend. In one of his other books, shows how you can take in 2 pages of Lisp code and turn a Lisp that is not a multi-processing Lisp that can only do one thing at a time, and make it into a Lisp that can do multiple things at a time, like a multi-processing system, using just macros. It's mind-blowing, but it makes Lisp very powerful, that macro facility. Okay, other data types, we have characters, strings, we have vectors, unidimensional arrays, we have arrays. Complex numbers are a data type itself. Structures, just like in def structs or structs in other languages. We have rational numbers, which I think I know I mentioned in both 140 and 301, are like that, for example. The usefulness of rational numbers is that, let's say, equals 1/3 divide 1 by 3. It may tell me true. To the limits of its precision, it's true. But if I look at this, thank you. If I look at this as a floating point number, then it's not true. So for example, I do this. It's not true because they're different. And so what happened here, floating point numbers is, some things you can't represent exactly in the computer. And so some rational numbers you can't represent exactly in the computer. And 1/3 is one of them. And so here it approximated it. By using rational numbers, you can avoid this rounding error, and this not rounding error, well, sort of rounding error, but this numerical approximation that goes on in trying to map things onto floating point numbers. And so often Lisp lets you use this to avoid things like round-off error and stuff. Okay. Now, as far as objects, Lisp does have objects. It's got the CLOS object-oriented programming system, Common Lisp object system. It's similar to C++ or Java, the way they do objects in some ways. It's not similar to Smalltalk. An earlier system, Flavors, was, which I actually prefer, but they didn't ask me, they just switched. We can define classes, for example, def, whoops, oh, def class student, and these would be the variables, the instance variables. So let's say name, name. If I just put nothing there, name and GPA, then that defines a class. Make instance student. That gives me a student. Describe that thing. And that tells me we have unbound slots, but there's the student. Okay, so that's typically how you do it. And if I want to set those, you can set them with slot value. You can check them with slot value, but in this case you get an error. Let me do this again so I actually catch that in something. Set S to be the student. And now if I do, if I look for the slot value, an S of name, it's going to give me an error because it's unbound. But I can set it using setF. And then if I look at it, set. Obviously, this is not the cleanest way of doing things. I could also define this by giving some other arguments here. I could say, for example, I can make this a list and say, look, an infection. They're trying to infect my Macintosh with a Windows virus. Good luck with that. Anywho, if I have I can say I want the init form. That's the initialized the form that you initialize it with to be Henry, or let's say Peter. And I can add an accessor, or I can say an init argument. So now I can tell it what the name is. I can also give it an accessor, so it creates new functions for me to access the thing. Okay, so let's just go with name. I'm not going to worry about GPA. Well, let's go ahead. What the heck, right? Got nothing but time here as I chew up disk space with the recording and your minutes of your life. So here, init form would be 4.0. We assume you all will make that. And GPA and GPA. All right. And now if I make instance this, describe, should just expect, it's got the name Peter and 4.0, and I can do slot value and get that or not. But I also have accessors now, so I can say name S, and it should give me Peter. If I want to set the name to something else, I can do a setF, name F's, and then say Paul. Just expect, okay? We can subclass things. Yeah, we'll not worry too much about that. We'll subclass things if we want. Say COS 470 student. Can't type at all tonight. Favorite type of student. Apparently not, because I can't do things right. It doesn't have any new instance variables. And now if I say, I apparently don't want to type, COS 470 student. Describe S. It says you're a COS 470 student, instance of that, and if I define, if I ask what that is, well, anyways, it gets defaults from the parent. Okay, if I want different defaults for COS 470 students, then I could say GPA 4.3. You somehow managed to achieve greater than that. Okay. Oops. Nope, it doesn't. That's not the way you do it, by the way. Just in case you're interested. That'd be the way you do it. And now if I do this and do this, okay, I got that. That's different now. It picked it up from the it inherited it. Why are you doing that? Okay, so basically like you'd expect anything else. You define methods on this with the function def method. Def method is somewhat different than you might be expecting if you've done other object-oriented things. Remember in Python, Java, things like that, methods are tightly associated with the objects. So you create the object definition, and inside of that then, you define the methods. That is not the case with this form of methods. Here we're using generic functions. So we define a function, def method. I can say def generic if I want to. I don't have to. But let's say I define def method print self. Okay, so it's a new function I'm creating, print self, and it takes arguments of, let's say, self, which happens to be a student. Okay, so we would say what this thing is. Self is a student. Notice this argument list looks different than it did before in that we have now qualified what that thing is. Okay, and now I would say, I can say with slots, self. Nope, I can say with slots, name, GPA, self. What that says is, remember I said that with dash something makes something true until the end. This kind of opens the scope, but it associates the name, not really. It associates this name with the actual instance variable, okay? So we have to do slot value and stuff, okay? So here, with slots is what it's called, sorry. Notice it didn't, this is something to notice. If you see weird indentation like this, it probably means you typed something wrong. So I see that weird indentation a lot. Now it's back where it belongs. So here I'll say print name, print GPA. Okay, and so now if I call that, okay, easy enough, right? Notice that S is really a COS 470 student, but this is defined for the parent. Okay, what if I want to do something different for COS 470 students? And then I can do something like, say, this. Because we're better than everybody else, right? And now if I do that, I get that. Okay, because now I've specialized it to that. If on the other hand I say make student name Henry, I'll just go ahead and I'm not saving anywhere. I'll just print it. Oops, not like that. I won't. So I make a new one and print it. Go ahead and print it. And I screwed something up. What did I screw up? Yep. Student name Henry. Interesting. Oh, because I'm an idiot. I mean, I made a slight mistake. Okay. Then it's different. Okay. All right. Just some extra, and that's it. Believe it or not, we are done. And so hopefully this has been somewhat useful to you, and hopefully you will get some facility with Lisp and enjoy Lisp. It is a fun language. I've been using it for, oh golly, I've been using it for a long time, 33 years now. And it's still, there are things about Lisp I don't know, and so there's always something to explore. It's a very large language these days, but it's very good for AI and for virtually anything, really. It's a nice language. Hopefully you'll fall in love with it like I did. You may come to hate it. If that's the case, enjoy Python later. But for this course at least, hope you enjoy it, and happy hacking.